This lesson is for Chapter 3, Section 4, Zeros of Polynomial Functions. This particular section ended up being quite long, so I split it into two different lessons. So this will be just the first half. So if all of you guys would open up your textbooks to page 275 and get your notebooks out, we will get this part started. All right, zeros of polynomial functions. We've been talking about them a lot as of late. Each nth degree polynomial, remember the degree is the highest power that the polynomial has. Each nth degree polynomial will have n zeros, so those two pieces are going to match. So the degree will match the amount of zeros that you should be able to find for the polynomial. If a polynomial has n zeros, then it must also have n factors as well. So for example, all of you know that if we find out that there is a zero for a polynomial of 2, that means it comes from the factor of x minus 2. The fundamental theorem of algebra states that if f of x is a polynomial of degree n, where n is greater than 0, then f will have at least one zero. So let's take a look together at checkpoint problem number 1 at the bottom of page 275. It says determine the number of zeros of the polynomial function f of x is equal to x to the fourth minus 1. All right, so notice on this one the polynomial is of degree 4, so that means that we should be able to find 4 zeros. Okay, degree of 4, so 4 zeros in all. So let's start taking a look at this one. Now, in looking at f of x equals x to the fourth minus 1, this is a difference of two squares. So I'm going to begin trying to find my zeros just by simply doing a factoring. X squared minus 1 and x squared plus 1. Okay, now x squared minus 1, the first factor that I broke into here, is another difference of perfect squares. So I'm going to take this first one and I'm going to break it and factor it again. Now the second end, x squared plus 1, does not factor anymore. That's a sum of two squares and that's not factorable. So let's just take a look at what we're faced with here and decide what our zeros all are going to be. Well, these first two are pretty easy. Positive 1, sorry. Positive 1 is the 0 for the first factor. Negative 1 is the 0 for the second factor. And on the last one here, let's just take the whole thing, set it equal to 0, and figure out what we come up with. So subtracting 1 from both sides, x squared is equal to negative 1. To unsquare x, we know to take the square root of it, which means we'll get plus or minus the square root of the other side. Now the square root of negative 1, if you remember back in a previous chapter, square root of negative 1 is I. So we're going to end up with either positive I or negative I as a couple more zeros. So there's all four of them. We have 1, negative 1, I, and negative I for the zeros of that polynomial. Okay, the rational zero test. Thought I'd skip two slides there. To find all of the possible zeros of a polynomial, you're going to have to consider all possibilities that come from this particular configuration. You're going to look at factors of the constant term over factors of lead coefficient. Now I'm going to warn you, this could end up being a lot of possibilities for zeros for a polynomial. I wish I could tell you that there was a better way than to flat out figure out how many possibilities there are and to start testing, but that's exactly what we're going to end up having to do. So if we're looking at checkpoint problem number 2 on page 276, find the rational zeros of each. Well, I'm only going to do letter A, I think. I didn't do, nope, that's all. Letter A for our notes, but there were a couple of more options that you could do too. I think there were two more. And remember that on that larsonprecalculus.com they do the videos for those if you want to look at some more too. So in looking at our factors of our constant is 8. So plus or minus 1, 2, 4, and 8 are all possible factors of that digit. Luckily on this one, the lead coefficient is 1 in front of our x cubed term there, so we only have options of plus or minus 1 for the denominator of the number that we check. Okay, so you just begin checking to see if those numbers work in your function. So let's just start testing. F of 1 would be 1 minus 5 plus 2 plus 8. And if you put all of that together, you're going to get 6. So that is a no. 1 is not a 0 for our function. So move on and try another one. F of negative 1. Then we're going to have negative 1 cubed, which is negative 1, minus 5 times negative 1 squared, which is going to be minus 5, plus 2 times negative 1, which is minus 2, plus an 8. We do get a 0 there, so one of our zeros is going to be negative 1. Go on, try 2. We get 2 cubed, which is 8, minus 5 times 2 squared, which is negative 5 times 4, or negative 20. Then 2 times 2 is 4. And that one is a 0. Okay. Try negative 2. Negative 2 cubed is negative 8. We'll still get negative 20 here. Negative 2 times 2 is negative 4. And I think you guys can all see that that is not going to equal 0. So f of 4. Keep moving on. 4 cubed is 64. 4 squared is 16 times negative 5 is minus 60. 2 times 4 is 8. Oop, negative 80, sorry, not negative 60. And the plus 8. So I've just found 3 zeros. And if you look at the degree of your polynomial, your degree is 3. So that should be all of them. So we're not going to continue on because we've just located our 3 zeros. We have negative 1, 2, and 4. All right, the next piece, to find the rational zeros when the lead coefficient is 1. It's really nice when that lead coefficient is 1 because it reduces the amount of possibilities that you have, kind of like our last problem there. Otherwise, when you have a lead coefficient of, say, 6, that's just going to continue to increase the amount of possibilities that you're going to have to check for those zeros. Figure out all your possible zeros and start testing. Once you find one, use the resulting polynomial to continue checking more, or you can maybe even factor what's left and finish up that way. All right, so a couple of options so that it's not quite so much testing like that previous example. Looking at this one, we're going to find the rational zeros of this f of x function. And looking at our constant, we have negative 125 back there. So your possibilities for the top of our zeros check, we could go plus or minus 1, 5s go in there, 25 goes in there, and then of course 125 itself, and that's going to be over plus or minus 1 because our lead coefficient of course is 1. Now a faster way to do our testing, remember yesterday we were talking about synthetic division. You can sure go ahead and see if any of these combinations of numbers work using synthetic division. It sometimes is a lot faster. So let's just start testing a couple of them. Let's go with a 1. So pick k as 1. Your coefficients, we have 1, negative 15, 75, negative 125. Drop the first one. 1 times 1 is 1, combine. 1 times negative 14 is negative 14, combine. And I think you can all tell that this is not going to, whoops, 61, that's not going to work out. So 1 is not going to be a 0. Move on and give negative 1 a try. So drop, times negative 1 by 1, combine, times negative 1 by negative 16. And again, I think it's pretty obvious already that this is not going to happen. All right, so next we have plus and minus 5 over 1. So let's give 5 a try. So be prepared, you guys, to end up devoting a lot of paper to some of these problems. So drop the 1. 5 times 1 is 5. Combine. 5 times negative 10 is negative 50. Combine. 5 times 25 is positive 125. And there we end up with our first 0. So yes, we do end up with 5 as one of our zeros. Now take a look at the polynomial that was left. Remember on that previous slide, I said you might be able to finish by factoring the remaining polynomial. So if we get that 5 out of there using synthetic division, we're left with x squared minus 10x plus 25. This is very easily factorable to an x minus 5 and another x minus 5. Now the zeros for both of them are 5. Okay, so all three of our zeros for this particular function end up being 5. Let's take a look at another one. Find the rational zeros of this function. All right, so when we're looking at this one, take a look at your end number, negative 30. And your lead coefficient this time is not a 1, it's a 2. So all of our factors of 30, 1, 2, 3, 5, 6, 10, 15, and 30, all over either of those four numbers as well. Okay? Now, when we write those out, of course, all of those top numbers over plus or minus 1 are either going to be plus or minus of what they are. So with having that plus or minus 1 on the bottom, we just have the top row. Okay, so we do need to consider or check or be prepared to check plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, 6, 10, 15, 30. But now let's have plus or minus 2 be the bottom option. Well, so we're going to have to consider plus or minus a half. But notice that if I put plus or minus 2 under the 2, that's plus or minus 1, and we already have that in our list, so we don't need to do it again. Move on and have the 2's underneath the possibility of a 3, so we do have to consider 3 halves. We do have to consider plus or minus 5 over 2. But now notice 6 over 2 is 3. It's already covered. We don't need to do it again. 10 over 2's, that's 5's. We don't need to consider that again. Plus or minus 15 over 2. And then the 30 over 2 is 15 again, which is already in our list, so we don't need to write that one down again. So it is huge, but some of those top numbers over 2 were already taken care of with top numbers over 1. All right, so again, I wish I could tell you there was some bigger, better, fantastic way of taking a stab in the dark, but let's just use synthetic division and give a couple a try. Now, oftentimes, I don't necessarily start with 1. I might go for the 2 or the negative 2 instead. I don't have any particular reason for that. So let's go ahead and pick k of 2 to begin with. All right, so drop 2 times 2 is 4. 2 times negative 5 is negative 10. 2 times negative 28 is negative 56. And 2 times 15 is positive 30, which does end up working. So 2 is in fact a 0, leaving us with 2x cubed minus 5x squared minus 28x plus 15 remaining. Okay? Now you're going to try some more, test some more. You're maybe going to find a bunch of them that don't work. Maybe you'll take a random stab at another one that does work. I'm just going to shorten this up for you a little bit and tell you that when I checked or when I got to testing negative 3, it did work again. So I am going to use my new polynomial that was left over after I got that first 0 identified and out of there. Drop it. I'm going to get negative 2 times 6 is negative 6. Combine negative 11. Negative 3 times negative 11 is 33. Positive 5. Negative 3 times positive 5 is negative 15. So you can all see that it does work again. Here was another 0. Now look at what you're left with. So just so you know, that negative 3 was not the next one that I tried. All right, so I had gone through the negative 2, I had gone through the positive 3. I backtracked and I tried the 1. And then I came back and I did the negative 3 and I found another one that worked. So it didn't come just luckily 2 in a row. I did have to do some playing around with those options. But now look at what you have. The polynomial that we're left with, this is a regular trinomial. Give it a look and see if you can do the quick end factoring here. So there's only one way to split 2x squared. And if we put negative 1 and 5 out there, so if we go negative 5 here and negative 1 here, we can in fact make that negative 11. So here's my other 0, and here's my fourth 0. And once we found the fourth one, since our polynomial was of degree 4, we know we've got them all. So 2, negative 3, 1/2, and 5 ended up being the 4 zeros that we were looking at. All right, let's try another one. Finding all the real zeros of this one. Again, it takes a little bit of practice just to get this whole big, huge list of possibilities to generate. But with our 18 in the back here for our constant, plus or minus 1, plus or minus 2, plus or minus 3, then 6 goes in there, 9 does, and 18 does. And nicely enough on this one again, our lead coefficient is a 1, so we do only have to consider that top numerator list of numbers. All right, so graphing this one, or the book suggests graphing and maybe giving yourself a bit of a sketch to try to narrow it down in some cases. I don't. I kind of tend to be one of those who just starts testing, and the synthetic division method is so fast, it really doesn't take a ton of time. This one though, you know, well, this one wasn't bad because positive 1 didn't work for me, but negative 1 did. So if you graph it or use your graphing calculator to give yourself an idea of where those intercepts are, you could probably narrow down this process faster. And obviously you guys know me well enough to know I don't use the graphing calculator very much, so that's not how I do it. Okay, so negative 1, like I said, I tested positive 1, it didn't work, so I tried negative 1 next, and it did. So now I have x squared plus 3x minus 18 left, and that was a very quick, easy trinomial factor with a positive 6 here and a negative 3 here. So my next 0 was negative 6, and another 0 was positive 3. So my zeros, and again it was a degree 3 polynomial, so it's good that I found 3. Negative 1, 3, negative 6. Now, just for practice sake, because as we get into part 2, this is going to be the end of part 1 for now, you're going to be asked to list the factors for these zeros. Well, if we were going to do that, okay, so the direction of this one technically didn't, but let's go there anyway. If your 1, 0 was negative 1, what factor would that have come from? Would have been an x plus 1. Okay, remember the factors are x minus k. If k ends up being a negative 1 like this one did, it must have been an x plus 1 factor that got that for us. So what's my next one if my 0 was 3? Hopefully you guys said x minus 3. My last 0 was a negative 6, so it came from the factor x plus 6. So a little preview into the future. If they would hand you to the zeros, okay, flat out give you the zeros and then say, write a polynomial function that would have these zeros, what would I do now to those factors that I just came up with to get the polynomial function? hopefully all of you are kind of thinking to yourself, well, if I just FOILed it up and multiplied it back up together, I would get back there and you'd be correct. Okay, so that's a little preview into the next half of this chapter. All right, so focus your practice on page 285 to start with the problems 1 through 40. Do a bunch of these. Get very comfortable with testing the options and coming up with these zeros in a variety of ways. The second half of the chapter takes them a little bit more in depth with a few other ways to narrow down how many zeros you try, or giving you an idea of how to eliminate some, or when to know when you can stop, and things like that. So if you can really get solid on these first couple of skills, or this first half, the second half is kind of just in addition to or bonus. All right, so we'll quit there for today.